First question, which are the important terms for the heat transfer from the fin system? That is, heat transfer from the fin as well as heat transfer from base surface. Second question, solve one problem on heat transfer from the fin system. Let us understand the different terms useful to solve the problems for the heat flow from fin system. In previous video, we have seen that how the heat transfer process is taking place through the fins. But here we have to refer the fin system. So what is the meaning of fin system? That is the heat flow from the fins as well as heat flow from the base of the fin. Now we will refer this diagram. If we observe, this is the wall with dimension x and y. We will consider length of the wall is x and height is y. Now fins are attached to these walls having length L, width W and thickness T. Now we have to understand different parameters with reference to this diagram. We will first move for the area of wall. So what is the area of wall? So suppose if we consider the dimensions, then we will consider this wall as a rectangle shape, and what is the area of wall? That is x multiplied by y. So we will write here. So a wall is the notation x multiplied by y. Then we will move to the next, cross sectional area of fin. So how to measure the cross sectional area of fin? So if we observe, this fin is attached to the wall with this width W and this thickness T. So I will highlight this area for the cross section of the fin. So how to measure the area for this highlighted portion? So here is width W and this is the thickness T. So W into T, that is the cross sectional area of fin. So ACS is the notation. So we will write W multiplied by T. Then we will move to the next, surface area of fin. Now we have to measure here the surface area. So what is the surface area? So this is the cross sectional area, and now I will highlight the surface area of fin. So this is the surface area that I will highlight with the help of red marker. So how to measure the surface area? So this surface area is the combination of this width and length. So surface area of fin, that means L multiplied by W, but here this is the upper surface, and what about the lower surface? So for lower surface also the same dimension is there, that is L and W, and this is for one fin. So we will write here surface area of fin, that is 2 multiplied by L into W. So this is the surface area of the fin. Now number of fins. So here the number of fins, that means that will be mentioned in your question. So here number of fins, that is capital N. So here number of fins are 2. So we will write here number of fins capital N is equal to 2. Then bare area of wall. So this is also important concept. What is the bare area of wall? Because these fins are attached to the wall. Now we have to find out what is the bare area of wall. So here the cross sectional area, that is width multiplied by thickness, is attached, that is this is the fin base. So I will highlight this area, the fin base. I will highlight this. So we have to subtract this cross sectional area. Now if we subtract this cross sectional area of the fin, then the remaining portion will be bare area. So what is the total area of wall? Total area of wall is x multiplied by y. Minus, so I will write here as a wall, because I will not write here dimensions. So a wall minus bare area of wall, that means from this total area of wall we have to subtract the cross sectional area of fin, but here we have to consider the number of fins also, because there may be one fin, two fin, or 50 fins or 100 fins. So we have to consider the number of fins also. So n multiplied by cross sectional area, that is cross sectional area of the fins. So this remaining portion is known as the bare area. So I will highlight here with the help of these vertical lines. This is the bare area of the wall. So we have to measure this bare area with the help of this total area of wall minus n into cross sectional area of the fin, that is ACS. That is, we have formula here how to calculate. Now we will move for the next, the net effective area of the system. So how to calculate the net effective area of the system? So for that we have to consider here the fin efficiency, that is the neta, and now net effective area, that means what is the meaning of effective area? So effective area, that means the area for which the heat transfer process is taking place. Now we will consider here this cross sectional area of this fin will be insulated at its end. That means the heat is not getting transferred from this cross sectional area of the fin, that is at the end of this fins heat is not getting transferred. Then what will be the effective area of the system? So if we observe from which area the heat will be getting transferred, so heat will be getting transferred from this bare area as well as from this fin surface. So we have to consider the fin surface, that is AF, then we have to consider the number of fins as well as we have to consider the fin efficiency. So we have to add this bare area. So bare area, that means AB, plus we have to consider the surface area and we have to consider the efficiency of fins. So I will multiply here neta into number of fins, that is N, multiplied by AF. So this is the formula, that is for the net effective area of the system, but with the given condition that at the end of the fin these fins are insulated or no heat transfer is taking place from the tip of these fins. We will read the given question. Heat is being transferred from water to air through a brass wall with K is equal to 75 watt per meter Kelvin. Heat transfer coefficients on water and air side are 150 and 15 watt per meter square Kelvin respectively. Size of the brass wall is 50 cm by 50 cm. Temperature of the water and air are 90 degrees Celsius and 30 degrees Celsius respectively. Neglecting the temperature drop through the brass wall, find the rate of heat transfer. It is desired to increase the heat transfer rate by adding 50 rectangular brass fins, 1 mm thick, 25 mm long. Calculate first heat transfer without fins, second heat transfer when fins are on water side. Assume that fins are insulated at the end and neglect the heat transfer from the edges of the fins. Let us understand the given data with the help of diagram. It is given that the dimension of the wall, that is length, is equal to 50 cm. So we have to convert it into meter, that is x is equal to 0.50, height is equal to 0.50 meter. Now in the same way for the fin, dimensions are also given. So length of this fin is given 25 mm. So we will write L is equal to 0.025 meter. Now the width is not mentioned, but the fin shape is given rectangular. So we can say that this width, that is nothing but this length of this wall, that is width, is also equal to 0.50 meter, and thickness is mentioned, that is 1 mm. So T is equal to 0.001 meter. So these are the dimensions. Now we will calculate the different parameters required for the calculation. So first is perimeter of the wall. So how to measure the perimeter of wall? So if we observe the dimensions, this is of square shape. So perimeter, that means addition of these all four sides, that is 0.50 plus 0.50 plus 0.50 plus 0.50, and that is equal to 2 meter. Then number of fins, n is equal to 50. So number of fins 50, that is mentioned in the question. What is the area of wall? So area of wall, that is nothing but this length multiplied by height, that is 0.50 into 0.50, that is 0.25 meter square. Then cross sectional area of fin. So we know that the cross sectional area of fin, that means this area, that is width multiplied by this thickness, that is 0.50 multiplied by 0.001, that is equal to 5 into 10 raised to minus 4 meter square. Then bare area. So bare area means what? So we have already seen that bare area, that means this total area of wall minus cross sectional area of the fins. So this cross sectional area of fin, that means the area which is attached to this wall. So we have to take here area of wall, that is 0.25 meter square minus number of fins 50 multiplied by cross sectional area, that is 5 into 10 raised to minus 4. So answer is 0.225 meter square. Then surface area. So surface area of the fin, that means we have to consider this upper surface as well as lower surface. So 2 multiplied by this length multiplied by width, that is equal to 2 multiplied by 0.025 into 0.50, that is equal to 0.025 meter square. Now we will move to the first question. We will find out the heat transfer without fins. Now if we observe, the heat transfer process is taking place from this water to the brass wall and from this brass wall towards the air. But here the one condition is mentioned in the question, that is we have to neglect the conduction through the brass wall. So if we observe, the convection heat transfer process is taking place from this water towards the brass wall, and again the convective heat transfer process is taking place from this brass wall towards the air. So we will use here the resistance for the convection heat transfer process. So resistance R1 is for convection heat transfer from this water towards the brass wall. So here the value of H for water is given. So we will consider here as a H1. So R1 is equal to 1 divided by H1 into area of the wall. That is 1 divided by 150 into 0.25. In the same way, the convective heat transfer is taking place from this brass wall towards the air. So we will calculate the resistance R2. So R2 is equal to 1 divided by H2 into area of wall. So H2, that is the convective heat transfer coefficient for this air. So 1 divided by 15 into 0.25. So now this heat transfer is taking place one after the other, that means R1 and R2 are in series. So summation of R is equal to R1 plus R2. So Q, how to calculate heat transfer Q, that is delta T by summation of R. So heat transfer taking place in between water and air. So 90 minus 30 degrees Celsius divided by R1 plus R2. So if we calculate this 0.026 plus 0.26, and answer is 209.79 watt. To calculate the effective area for heat transfer, we will first calculate what is the efficiency of fin. If we observe the diagram, here this water is on the fin side. So how to calculate the efficiency of fin? So for that we have to first find out the value of M. What is the formula of M? That is under root of Hp by Ka. So H is the convective heat transfer coefficient. Water is on the fin side, so there is the convective heat transfer from this water towards the fin. So we will refer here as a suffix 1, that is H1. Then what is this P? That is the perimeter of the fin. So which area for the perimeter that we have to select I will mention here. So we have to select this area, that is the cross sectional area of the fin for the calculation of perimeter. So I will highlight this area. Now what is the perimeter? So perimeter, that means addition of all the sides. So we have to take this width, that is 0.50, plus thickness, that is 0.001, plus width 0.50 plus 0.001. So when we calculate this perimeter, then we get the answer 1.002 meter. Now next term is K, that is the thermal conductivity. So conductivity of this brass material is mentioned in the question. Then what is the area? So here we have to refer the cross sectional area of the fin. So again, for the cross sectional area, that means this area I have highlighted earlier, we have to calculate this area. So how to measure this area? So this is of rectangle shape, and here is W and here is T, that is width and thickness. So we have to calculate the area, cross sectional area of the fin, that is W multiplied by T. That means 0.50 multiplied by 0.001, which is equal to 5 into 10 raised to minus 4. Now we will put the value. Now here water is on the fin side, so we will take here the convective heat transfer coefficient for water 150 into P 1.002 divided by K, that is 75, and area of cross section, that is 5 into 10 raised to minus 4, and we have to take the square root. So answer is 64.80. Now we will calculate the efficiency. Now here condition is given, that is we have to take the fin is insulated at its tip, and it is mentioned in the question. So when the fin is insulated at its tip, that means there is no any heat transfer, or we can say the temperature gradient, that is equal to 0. So what is the formula when the tip is insulated at its insulated? So we have used the formula, efficiency of fin is equal to tan H m1L by m1L. So m1 is already calculated. So here hyperbolic function of tan, and we can calculate with the help of calculator, that we have to press plus hype button, that is the button for the hyperbolic function, and then tan button, then we will get the value of tan, and in bracket we have to put this value. So when we calculate this, we will get the efficiency of fin 0.57. Now we will calculate the effective area on water side. So how to calculate? We have formula, that is effective area on water side, that means bare area plus number of fins multiplied by the surface area of the fin multiplied by the efficiency of the fin. So what is the bare area? That we have calculated earlier, 0.225 plus number of fin 50, surface area of fin. So surface area of the fin 0.025, that we have calculated earlier, and efficiency of fin 0.57. So answer is 0.9375 meter square. Now we will find out what is the heat transfer from this water side towards this air side through these fins. So how to calculate this? So heat transfer is taking place in between this water and air. So we have to take the temperature difference, that is this temperature of water minus temperature of air, that is 90 minus 30 divided by. Now this step is important. Now first we have to calculate the resistance for convective heat transfer from this water to the fin. So how this is taking place? So for that we have to take this convective heat transfer coefficient of water H1 multiplied by the effective area of the fin. So this is very important. We have to measure the effective area of fin that we have calculated earlier, that is 0.937, plus we have to take the resistance for the convective heat transfer from this brass wall towards the air on the back side. So how we can calculate this? That is, we have to take the convective heat transfer coefficient for air, that is H2, multiplied by the area of the wall. So because of this whole area of the wall is in contact with air. So here we have to refer for fin side effective area of the fin, and for wall air side we have to refer here area of wall. So this is important. So 90 minus 30 divided by 1 divided by 150 into 0.9375 plus 1 divided by 15 into 0.25. So when we solve this, we will get the answer 224.62 watt.